This is a question from GATE 2023, question number 20, and it says that let C01 is all set of all function whose domain is this, from range is R and they are continuous. Consider the metric space. We have a metric space of C01D infinity. C01D infinity, where D infinity Fg is equal to supreme of fx minus gx, x belongs to 0, 1, and those who knows that it is nothing but simply f minus g sup norm. This is same as this. Okay, so f comma g belongs to c0, 1. Let f0x, which is equal to 0 function. This is a 0 function. This is not an this is value at 0. F0 f naught is a function whose at any point x value is 0 for all x belongs to 0, 1, and let x is equal to those f belongs to c0, 1, d infinity, that's it, that is this set, such that d infinity, the metric f naught comma f, is greater than or equal to 1 by 2. This is our x. So let f1 f2 belongs to c0. F1 is given by f1 x is equal to x, f2 x is equal to 1 minus x for all x belongs to 0, 1. Consider following statements. F1 is in interior of x, F2 is in the interior of x. So we need to check if like how does x, let this is be x. Just for example, x doesn't look like this. Let's just assume that x. So if this is F1 and if we can find an open ball around it and it is contained in it, then F1 belongs to interior of x. Similarly, if we can find for F2 an open ball around it which is contained in x, then this implies that F2 belongs to interior of x. Okay, first of all, let's just see once what is the distance between f0 comma f. This will be equal to supremum of f naught x. From this definition, x minus fx, where x belongs to 0, 1. This is just another notation, nothing else. This is 0, so this will be equal to supremum of x belongs to 0, 1 of fx f1x. This is equal to f1x is x, this is equal to 1. So we have like this, if we consider like this, f0 and this is f1, their distance between them is somehow 1. Okay, so let us consider a ball around f1 which is of radius 1 by 4. You can take another value from 1 by 4. There is nothing special about 1 by 4. You will see why 1 by 4 works, and similarly other radius will also work. This is all g belongs to c01 such that f1 minus g, okay, we are d infinity f1 minus g is less than equal to 1 by 4, is strictly less than 1 by 4. Okay, so according to, we need to show that there is a ball around f1 which is contained in x. Okay, so here we will show this. Bf1 1 by 4, this is actually an open ball at center f1 of radius 1 by 4. Okay, it's contained in x. Okay, so let g belongs to bf1 1 by 4. Then what does this imply? This implies that d infinity, this is comma here, f1g is less than 1 by 4. To to show G belongs to X, which is equal to, what is X? X is those F belongs to C01 such that D infinity F0 comma F is greater than 1 by 2. So we need to show that D infinity G comma F0 is greater than 1 by 2. Okay. Alright, we will use triangle quadratic here. First consider D infinity of F0 comma F1. This is like less than equal to D infinity F0 comma G plus D infinity uh, F1 comma G. Okay, we just keep it like this, and we have calculated this is 1. And what about this F1 comma G? Nah, wait a second. D infinity gamma, this is equal to supremum of F1x minus Gx, where supremum is taken along 0 1 closed interval. Oh, okay, wait a second. Where is this G? G belongs to, remember this G belongs to B F1 comma 1 by 4. So D infinity F1G is less than 1 by 4. Okay, so we get, so this is less than 1 by 4. Now this implies 1 minus 1 by 4 is greater than D infinity F naught comma G, and I think yes, this is greater than 1 by 2. So we have the distance between F naught comma G is greater than 1 by 2. What does this mean? This implies G belongs to X, and G was taken any element from this open set, and it is contained in X. This simply implies that B F1 comma 1 by 4 is less than is a subset of X. You can see that 1 by 4, main purpose of 1 by 4 is that it is just strictly greater than 1 by 2. You can take any value that will make it strictly 1 by 2 greater than, so that this belongs to G, this belongs to X. This is the purpose. You can take any other value. Okay, thus, so what we have find, an open ball around F1 such that B F1 1 by 4, which is a subset of X. This implies that this is X, say, and this is F1, and we have find an open ball around it. This implies that F1 belongs to interior of X. In a similar way, you can show show that F2 belongs to interior of X2. Thus, both F1 comma F2 belongs to interior of X. So now getting back, so both P and Q are true.